Hey Pre-Calcers, a few more problems that we're going to talk about from the 5.1 practice. Recall that the first page you should have taken notes on looks like this. As I move forward, I'm going to be referencing a lot of the identities on here. So chances are if you're getting stuck with 5.1, just keep looking back at this and think, is there anything I can rewrite? Or if it's a Pythagorean identity, can I rewrite one of those? Let's take a look at 9. This is dealing with cosine squared of x, subtracting sine squared of x, and we're claiming that it's equal to 1 minus 2 sine squared of x. So this can be a little challenging. One thing that resonates with me when I look at this is that we have a sine squared of x. Was there a specific Pythagorean identity that has sine squared of x in it? Hopefully you're saying the one where we have sine squared of x, and if we add cosine squared of x, that equals 1. So what's cool is that we can manipulate this equation here and try to work through it and rewrite it so that we can, in my eyes, definitely we want to substitute in something for cosine squared of x, because this already has sine squared of x, and this is already sine squared of x. So chances are trying to manipulate this is going to be your best bet. So if we take a look at our Pythagorean identity and we're trying to solve for cosine squared of x, we can deduct sine squared of x on both sides. And if we do that also to the 1, this leaves us with cosine squared of x equals 1 minus sine squared of x. So in place of cosine squared of x, I'm going to put in parentheses 1 minus sine squared of x. Which again is fair game. We're allowed to do this because cosine squared of x is just another way that we could rewrite 1 minus sine squared of x. So let's write the rest of this. All right, and then on the left side here, what can we combine? What can we take further? Well, although I put parentheses around 1 minus sine squared of x, you should notice that we can combine the second sine squared of x with the first. So since we are deducting sine squared of x here and deducting it here, it's as if we're subtracting two versions of sine squared of x. And then lo and behold, we're now left with the right side. 1 minus sine squared of x on the left, 1 minus sine squared of x on the right, so we're done. So it really came down to rewriting this cosine squared of x. So that's 9. We're also going to hop over to 15. So this has sine squared of theta multiplying with 1 plus cotangent squared of theta. We're claiming that this is equal to 1. So sine squared of theta, there's not too much we can rewrite there. 1 plus cotangent squared of theta. However, do we see a Pythagorean identity that deals with 1 plus cotangent squared of theta? Down here. So we can rewrite the 1 plus cotangent squared of theta to cosecant squared of theta. So let's do that. So I'm rewriting sine squared of theta, and instead of 1 plus cotangent squared of theta, I'm going to put cosecant squared of theta. And eventually we're going to say that this is all equal to 1. So cosecant squared of theta, recall from our identities back here, we can rewrite that as 1 over sine of theta, and since we're squaring it, just rewrite it to 1 over sine squared of theta, multiplying with the sine squared of theta from the first step, and So we're in a pretty good position here because we're just multiplying these two fractions out. So let's do that. 1 times sine squared of theta. It's going to give you sine squared of theta up top. And if we multiply in the denominator, 1 times sine squared of theta, again, just sine squared of theta. We can see that we have sine squared of theta up top and also in the denominator. So these cancel. So since everything cancels in the fraction, we can just claim 1 equals 1. And then we're done. So pretty simple to just spot what you needed to rewrite. For 16, see if there's an identity that involves 1 plus tangent squared of theta. What else? For 17, see if you can rewrite tangent of t. There's definitely a way that tangent can be rewritten. For 18, see if you can rewrite cotangent of t. Look for where on the cheat sheet you saw ways that those can be rewritten. Think about the fractions and how those could multiply out. And for 19, see if there's a way that you could rewrite cosecant squared of t. And you may want to rewrite cotangent of t too. But I'm confident you can get through these. I hope that this was helpful. If you're still stuck, let me know if I can help. Thanks for watching.